Hi, I'm Larry, CEO, and in particular the CTO of Summit Imaging. We are an ultrasound and mammography equipment support organization. We're based in the Seattle area in the Northwest. And what we're here to talk about today is some software that's in development that we want to preemptively share before release to market. Because what we're doing here is really seeing a massive market transition in the consumer market of electronics, of looking at data that could be distributed from any local consumer electronic device being pushed to a cloud and therefore doing something for us. But even more important, using this data to run machine learning algorithms and whatnot against that.
The Internet of Things? The Internet of Things?
Sorry.
The Internet of Things?
The Internet of Things. I intentionally left out the IOMT because it doesn't really make sense to me. The Internet of Medical Things is just the Internet of Things. It's all electronics at the end of the day. It's a little bit more security because of healthcare regulations, but at the end of the day, it still is just sensors deploying information to a memory chip, and that memory chip being deployed via a network card to somewhere else, so we can aggregate the data. But why are we here? We're here to talk about a piece of software that we'll introduce later in on the slides. We kind of wanted to talk about the topography of the IoT market as it sits today, what we see going on, and want to have a discussion with you because you're on the ground level as well to see if you're starting to experience this transition of service really moving towards that cloud platform and seeing if this kind of fits that model in your opinion. We partnered with many to build this product, and we're really excited to share it with you today. So about us on what we do and why we're able to develop software. So if you look at solutions for HTMs in the market, there's really 5 driving factors here that make us fairly unique. The first and foremost is our customer partnerships. Our customer partnerships with large healthcare networks, a lot of reference accounts, have come to us looking for solutions to their problems. So we're able to partner with them to build software, to build supply chain solutions, to repair their transducers, repair their ultrasound parts and manual panels and all that. So we think that with that short feedback loop that we have with end users allows us to quickly interpret exactly what the pain points they're feeling, and then we can go to work and see if we can build a solution for them. The next one is electronic hardware experts. We repair everything on the component level. So we work on ultrasound equipment, we work on mammography equipment, but really where we sit is not looking at the type of equipment it is. If it's got capacitors, transistors, fiberglass, it's got traces, it's got VGAs, ICs, FETs, you name it, we repair down that level. And so when we're working in this healthcare industry and everybody's working on this defective core model, that's how we repair your equipment, is diagnosing down the component level, then replacing the component as necessary to bring it back up to full functionality. Software solutions development, we'll talk more about that here in a minute. We had developed a piece of software called Adepto, which was our first software development. KV is an iteration of Adepto down the line. But in being able to work on a lot of this electronics that we're seeing in the newer generation machines, so previous generation ultrasound machines and now current generation ultrasound machines, you're probably seeing that there's a lot of service hurdles in the way for you to service your own equipment and bring in that HTM service in-house. And so what we're talking about is getting very simple log files to find out what the fault was that the sonographer saw on the screen. What time it happened? Did it really happen? Is it a critical fault? Is it a level 0 fault? That might be a preemptive failure. It's all hidden or inside a hard disk. That's very difficult to get to. We developed some software that accesses all that information on the native hard drive and then extrapolates that information so you can read it and make a decision on equipment diagnosis immediately. And then off of that, we have built KV, which is a deviation of Adepto. We'll talk about that a little bit. We're ISO 13485 2016. Our QMS is certified. Just want to be clear, we are not ISO certified. Our QMS is certified. And so when you're hearing that, just to be very correct in the way that we're portraying what that means, is that our quality management system that is to ISO 1345-2016 standards is certified by NSAI. That is an annual audit where they actually come out on us. And that touches on a few critical factors. Federal regulations, are we abiding by the regulations that are set out there? Quality processes, customer feedback loop. And I think the most critical that separates this from the rest of the pack, a lot of ISO systems out there, is that this focuses on product reliability improvement. And so it's a constant improvement process that your processes that you build go through. And we've seen a massive benefit of visibility and insight into what we're looking at and on trying to lean out what we're trying to accomplish for quality. And it's been a wonderful system for us. And our customers absolutely love it because they have instant insight into, if there is a failure, we're in the repair business. Things don't go perfectly every single time, but we quickly understand what went wrong and go and correct that with a CAT button. And sophisticated tools. We have a lot of sophisticated tools, down to electronic repair. We have industrial X-ray that sees ultrasonic wire bonds inside of BGA, so we can identify if there's an open or it should be a short. We can see cold solder joints. We can see, do optical image inspections as well. So you can take a giant PCB. We can actually scan the whole thing in 20 minutes. And we can do a pixel map correlation in comparison to something that's functioning. So if you have something that's blown up, maybe a BGA that's burned, it'll actually tell you what area to look in for us to go diagnose with our electronic technicians. Super cool technology, and we do a lot of reverse engineering on circuits. So we're building our own schematics by using a flying probe that is a robot that we can program, and we program all the correct test points and all connectors and all these different things, and it's stored, and then we can put that board in, immediately identify where the failure is going to be. And so with all these technologies combined, it's useless without great repair technicians. So it's tough right now to find really the old school skill set where somebody can sit there with an O-scope or a DMM and repair down to component level. That's what we do. So we're constantly looking for those people. And with these sophisticated tools, accelerates that diagnosis to get down to that transistor that was failing and causing noise. And at the end of it, it's all of these things put together that allows us to build more solutions for the HTMs, and KV being a new solution that we're going to be offering to the market. Any questions on what we do? So what have we penetrated so far with all of these? Because the vision for our organization is that we can work on any electronic device inside of a hospital. Doesn't matter what it is. We just happen to fall in ultrasound first. But we've expanded to mammography. We do detector repair. We do replacement parts. We have technical support for it. We have hands-on training that Kyle hosts. And interestingly enough, it's the exact same model where we started, which is ultrasound. Transducer repairs and replacements, replacement parts, 24/7 technical support, and hands-on training. So if you look at the previous slide here, it's the exact same skill set to move into any electronic device in a hospital. So we have our strategic plan of moving into other imaging modalities. And in doing so, our software is going to help us do that because we're going to be able to understand what the failures are going to be for us to understand the problem before developing the solution. And so that the power in the data is going to show where the path of least resistance is going to be. So in software, we talked about Adepto. That is patent pending technology. That is the world's first alternative to onboard service diagnostics for major ultrasound systems. This works on the Philips Epic 5 and 7s. This works on the Philips IU22 and IU33, Logic E9s, Vivid E9s, you name it. All the current generation machines, it works on. And what this does is it allows a clinical engineer or an HTM to instantly slave a hard drive to their laptop with Adepto running on it and pulling all the pertinent information for you to make a diagnosis of what's wrong with your machine. And so, for example, the circumstance where an engineer is called to a site and says, hey, the sonographer says, I saw this error at this one time. You need to come out here and look at it. Like, well, did you take a picture of the error? Do you know what the error is? No, I just rebooted it because I'm busy. I'm working on this patient. I just rebooted it and I just kept going. Well, you're kind of diagnosing and troubleshooting in the dark at that point from an engineering perspective. Adepto allows you to pull that information, knowing date, time, error, and what's most important, what happened right before that happened. And so you may see a high voltage power fault, but you may actually see what drove the high voltage power fault. It might not be your high voltage power supply. It might be something else that's pulling it down and out of tolerance. So Adepto is an extraordinarily powerful and extraordinarily successful piece of software that's out there, and all of our customers use it to diagnose their machines. But Adepto grew, and it said, hey, our customer said, your diagnosis is awesome. I see what I need to see now, but it is half the battle. I need to know what, I need to do something with this. So if I know that particular part will fix my machine, but when I put that machine in, a part inside that machine, I get an anticipated fault code. And that fault code really means, hey, I see something different inside my machine and I need to do something. My software on the machine itself says, red flag, you need permission to install this part. Well, Adepto does that for you now. And it's something that we offer to our customers, where you have these sophisticated parts that you need to flash. You may need to install firmware, update firmware, whatever you need to do. Adepto does all those critical functions to keep your service in-house. So you don't have to extend your downtime by calling in a service engineer that may have the passcode when you're sitting in front of the machine and you know exactly what you need to do. It's 2 clicks beyond that passcode field. Adepto allows you to instantly do it and not wait for anybody. And it completely compresses your downtime, yes.
So I see Philips, those guys come up with new software every time, kind of put you guys out of the game. So how do you guys correct that?
We have kept up with the revisions of software very rapidly. So we are up to date with all the support. I think the biggest thing with the new Epic 5 and 7s, there was actually a hardware shift where it's a RAID setup now. And with the RAID setup, we just implement Adepto differently. And once it's implemented, it actually functions in the exact same way. Because an operating system doesn't recognize a RAID, it still is just an operating system. Whether it's running off of 3 drives or just 1, it still recognizes itself as its own instance. So right now, we've been very successful on keeping up with all the revisions. And the revisions we typically see from the OEMs is generally not security related. If we talk about security of the machine, it's typically just amping up whatever McAfee antivirus they have on the machine to battle things like WannaCry and all the cybersecurity things that we keep hearing about. But when you're talking about the actual raw native files on a hard drive, we're not seeing too much movement there. That's not really an issue for us right now. Anyways. Did that answer your question?
Right. So which software level right now you guys master than the Epic 7? What software level do you guys know?
Up to the latest software. I think it's 6 something now. Yeah, it works in all of it.
I haven't experienced any issues. Mostly because even though they continue to update it, the underlying base software stays where it is.
How are you marketing this? Is this a software package you sell or lease, or how are you marketing it?
So it's a subscription where our customers can pay to use the software. It's an annual license. However, we were seeing that our customers are saying, hey, this is actually a part of a larger solution that Summit Imaging is offering. So they end up wanting to actually engage in a larger capacity than just software. They're saying, if you have the software you can diagnose, then we can put together a supply chain solution for ultrasound parts just coming right into the system to cure all of the diagnostics that are occurring here. So the pricing varies. We can chat about that offline if you would like. But we're seeing that more customers, often than not, are using this as a leverage point to use Summit Imaging as a preferred supplier for their ultrasound content. And so from Adepto gives us a lot of functional use of an operating system that is traditionally removed in embedded systems. So when we're talking about Windows embedded, it is a Windows operating system with everything stripped out of it. And that's what all of our medical devices, not all, most of the medical devices are running nowadays is probably a version of Windows, believe it or not, XP, Windows 7, Windows 10, and Windows 10 is just now coming out.
But modified.
But being embedded, there's no UI, there's no DLL packages that allow you to install anything you want. But what Adepto does is it allows you to access the operating system, and we're able to perform a lot of functions that are traditionally not available. And you're going to ask, well, how do you do it? Well, that's kind of the secret sauce of Adepto, is that we're able to do it. Now, I want to be really clear. This is not infringing on any IP. This is not infringing on any HIPAA, because we're looking at metadata of an ultrasound system. So all of this is absolutely being used today by many OEMs, because the ease of use of the software allows them to instantly diagnose. So now, being inside of Windows, we'll talk about KV in a moment, but we were able to run KV, which is partly this software development piece, which is connectivity of ultrasound systems and more to distribute data to platforms. Then we can do a lot of things with that. So now let's get into the meat and potatoes of what is IoT. So IoT is still fairly new, and there's a lot of definitions out there. And there's a lot of definitions where they want to overcomplicate what this is really doing. And we did some homework, and we like this the best. So at IoTforall.com, the Internet of Things is actually a pretty simple concept. It means taking all the things in the world and connecting them to the Internet. That's it.
May I ask? Is this the ultrasound one?
Yes. And so it does one of three things. It collects information and then sends it. It receives that information and then acts on it, or it does both. So that's really important to understand. It's that simple, because the IoT is everywhere in our lives.
To do this, are you coming in on a VPN or?
May I answer that in probably 10 slides down?
Okay.
It's an easy thing to say, but I don't think everyone grasps things.
Fair. And I think that's why this market the potential is enormous. Because if it's an electronic device, the way I would think about IoT is if you have a sensor, that sensor can then put information into a memory chip, and that memory chip can then deploy it with a network chip going somewhere else. That is an IoT technology. Now, IoT becomes very powerful when you have a feedback chip where you get information back and then you do something with it, maybe locally on the machine or deploy into your mobile device. But it could be anything. I mean, we started with IoT of, Wemo outlets. Just turn on and off your lamp. That's constantly on an on state on the switch.
It could be the sensor that's in my chair right now that's determining the
Absolutely.
the amount of pressure I'm putting on it.
Yep,
To
and
see if
it might
I'm actually learning.
Fair point. So it's everywhere. My watch is an IoT device, right? So it's
It's gonna be socks, shoes, shirts, jackets,
everything.
things.
Yep, Internet of Things. And like I said, if I actually thought about it technically, I would look at that from sensor, memory, network chip. Those are the three components that are required to perform this technology. And it could be a simple function, and it could be a sophisticated function. But the research that we've done is IoT is always starting simple. And then the data it aggregates allows for more sophisticated implementations as it matures. So the industry is very quickly adopting IoT. So within healthcare, not as quick. That's just the nature of the beast that we're in. A lot more regulation that we have to go through. And really the risk palette within medical and healthcare, a lot less than other industries, right?
I've actually heard the opposite, that there's a lot of people that medical technology is leading the pack because the brain's behind it, brain power, if you will, is pushing.
Yeah, I think the aggression in the push and the effort is in healthcare, but if you look at the history, it's implemented elsewhere first. So if we look at manufacturing is one, the IoT technology on inventory and supply chain management, that's why Amazon's the biggest company in the world. That's what they've mastered, right? Transportation, I'm not sure if anybody has a modern car, but these cars are constantly connected to the internet now. I mean, there's actually a cell card inside cars now where it's communicating your diagnostic data to the manufacturer constantly. Now, is it doing the driver any good? Probably not, but it's really valuable data for the manufacturer to make improvements to the product, right? In energy, a lot of these panels, in Washington, we have a lot of solar and a lot of the windmills, and they're all spread out very far away. So they're connecting these with IoT technology to understand the performance of all those devices because it takes too long to drive there to go take care of it. Yeah.
What's the security?
Security of KV?
No, of the Internet of Things. If you start connecting everything, what's the, what type of security do you have to make sure that, they're not hacked and
Fantastic question. So there's a lot of different, so security is actually its own presentation in itself. So let me try, I'll hit it later down here lightly, but we'll jump on that topic a little bit. And what's nice about what we're providing is that we actually prefer out-of-band connectivity, and we'll talk about that in a bit, because out-of-band is really its own, like a closed circuit communication line. And the other is just mimicking what's already in the IT infrastructure of the healthcare facility. Gartner, they're saying there's going to be 26 billion IoT devices by 2020.
So this is the way.
It's the future. It is the future.
It's a tsunami.
Right? And it's driven by a lot of things. It's driven by the population density. I was just driving here from Orlando, and I just got here a couple of hours ago. And it feels just like at home in Seattle. The traffic is horrendous. My travel radius back home in Seattle in the last 15 years has geometrically decreased on where I go by virtue of the density of the population and traffic I face to need to get anywhere. How many people have that problem now? Well, you guys have to just raise your hand.
Yeah.
If you don't, you're so lucky, and I'm really jealous because it takes me 45 minutes to get 10 miles sometimes. It's terrible, right? But with IoT, it allows me, here's a personal experience, I have security cameras all over my house. I don't have to rush home because I can look at all my cameras and know exactly what's going on in my house to know if I have to rush home or I can just stay a little bit longer in the office. And so it makes your life more efficient by giving you the information that you need to make a decision. And now with the resource of time being compressed by virtue of population density, we're from the West Coast, so if you go to Seattle and Portland in particular, you can't get anywhere. It is awful. You just can't get anywhere. So we rely on our technology to give us the information that we need that we once would just drive to go figure out. So IoT for all, uses for healthcare, and these are 5 things that you're probably talking about. Reducing emergency room by wait time by 50%. I think that's by AutoBed with their service right now. Remote health and monitoring. Anybody have an Apple Watch? It's created by the FDA for EKG now, right? That was pretty recent, last couple of months. I mean, that's just a consumer piece of electronics that's monitoring EKG. But there's also tracking staff and patients and inventory. That's borrowing kind of IoT technology of logistics and supply chain. Enhanced drug management, they have sensors that, I was reading, they have a sensor that you swallow and actually measures the dose that your body absorbs of medication to give you a precise, so they can deploy the precise amount of medication to where it's optimized for your body in addressing chronic disease. So you see all that is really forward-facing towards the patient. And now, signs of entering HTM. Well, MRI monitoring, there's a couple of third-party choices that are fantastic choices, but Philips is now doing e-alert for the MRI, so they're actually monitoring MRI machines remotely, which is a phenomenal service. I think it's fantastic. But the other thing was, we were already seeing this coming. So Manual deployment of onboard files. Have you ever heard of an engineer needing to sit down in the machine, whether it's ultrasound, cath lab, whatever it may be? Hey, go plug in your USB flash drive, click on this button. It may or may not encrypt files. Push it to that USB stick, and now take that file on the USB stick, go send it to somebody, because you can't read it. That's the first step of it automatically just pushing to somebody so somebody can read it. And so what we're seeing is that on these legacy devices, there already is an option to take that information, shove onto a memory device, and then you email it to somebody who knows how to look at it. You can automate that process now.
Right now, I need to move logs, ultrasound logs.
Mhm.
I'm Carlos Molina from Kaiser Medical, Southern California. I mainly do ultrasounds. So some of the newer, especially the newer ultrasounds, the logs are so intense because they mesh, I mean, they'll do anything from a boot up sequence down to the keys you press to try to figure out intermittent problems, especially intermittent problems. They're over 5 meg. I can't move them over traditional email because of security reasons.
Yep.
So I'm having to go through VPNs and also to FileZilla's secure to move logs over, which is like intensifying and drag it out already an intermittent problem.
Yep.
We're talking about weeks, which is not.
Yeah, that's not good. When we get to that part of security, I'd like to offer up the solution of out of band. There are 2G technologies that are really cost effective, that you can do at scale, and allows you to transmit 5 megabytes, no problem.
But have you ever tried to compress the file?
You
Well,
can't.
the antivirus that Kaiser runs is gonna see that as a
Yeah, you
spam,
can't, you
and it's
cannot
gonna block
compress
it.
it either.
Yeah, Kaiser has, all of Northern California hospital networks have just insane amount of security.
Yes.
And it's total Banner Healthcare down there, it's kind of Southwest as well. But some are more diligent about trying to do things, and it is common that it will actually infringe on the capability of an engineer trying to do something very simple. And a big one is, I can't even write to a USB flash drive, right? That's.
Yeah, we have an encrypted where any USB drive put into any IT controlled PC is encrypted.
Yeah, and so what's interesting to me, and I'm not here to poke holes in security,
No,
but
ask
how many of you, raise your hand, do you access your email by your cell phone? Yeah, how many of these are locked down by your employer? Right?
Yeah.
Only a couple. This is a medical device now. If you were looking at patient information,
This is
if you
HIPAA
were-
safe.
Hmm?
iPhones are HIPAA safe. You can actually take a picture because of the encryption through Apple.
Yeah.
You can take patient demographics and it's HIPAA safe.
yes. So I'll talk about that platform in a minute on HIPAA security, GDPR ready. I think that's coming to us as well. The European Union just passed GDPR, which is a privacy act that the US is bound to adopt a similar version of that here pretty soon. But another sign of IoT entering HCM, they're asking us for it. Our biggest customers are saying, hey, we have a problem. I want to know this information. I want to know it now. I'm sick and tired of driving 3 hours to this one site to go figure out that it's a 001 error when I can know it's a 001 error now and get the appropriate replacement parts deployed right now. So I don't have to drive, 3 hours to get there, 3 hours back, wait for the part to get to me, drive another 3 hours there to do the installation, and then 3 hours back. That's all for one machine. That's in a rural area. So we've actually built a version of Adepto and a blend of Adepto and KV for one of our customers that works in all of those cath labs, actually. So one of our customers is actually monitoring 200 cath labs they have under their service arm with 2 engineers that work from their home. So why are they asking for it? One of the big pain points, what we're hearing is flexibility with instant knowledge of fault severity. What we're hearing is that most of the faults being reported by end users are not severe. You can just reboot your machine, it'll be fine. Or that fault is user-induced, maybe. Or that fault is intermittent, let's log it and let's see if it comes back. It might have been a voltage drop in the wall. Our customers want to improve patient care by increasing equipment uptime. When we're looking at maximizing equipment uptime, it's the diagnosis phase is the most severe portion of that service call. And servicing a piece of equipment on inaccurate diagnosis, to me as an engineer, the most frustrating part of the job. I thought I had this thing nailed out. User told me it was this error. I've seen this a million times. I come in, I put in the correct parts to resolve the machine, it doesn't fix it. Come to find out, it's actually a completely different error. That error was on that machine over there. This one has a new one altogether. So the accuracy of the information is really critical. We're seeing HTMs looking to build more sophisticated service strategies to take advantage of the shrinking workforce and the shrinking talent that we're going to start seeing in the HTM community, right? The baby boomers have been carrying all of us on their backs for all these years by keeping this equipment up. Well, they're all going to start enjoying retirement in beautiful places like this in Clearwater. There's no other generations that are really behind them to carry that workload anymore. And we believe that the future is leveraging technology to pick up that workload to supercharge HCM's activities and reducing the mean time between failure. As you aggregate data and look at what's failing across a fleet of machines, you can actually reduce and deduce what to do with your service strategy to prevent failures in the future. We see very often where there is actually streaks of failures at certain sites. You can actually catch this maybe on phase 2 of that story instead of failure 10 of that fleet of equipment to keep those machines up and going by preemptively servicing them. So what's the service potential of this? Very much similar. This is nothing new of the consumer market. We want to enhance the HTM geographical coverage capabilities. So as the workforce of HTM shrinks, what's going to happen? Well, there's going to be less HTMs, but there's not going to be less equipment. There's going to be more equipment. So you have to increase their geographic reach. And we can do this with technology. It reduces the HTM required time to service, one of our favorite parts about this presentation. We'll show you a timeline on how it impacts a service life cycle. HTMs can manage a fleet of devices by managing by exception. Right now, it is protocol to go look at every single device. And then once you're done, you start doing that cycle again, go look at every single device, right? That's your PM schedule. Very critical, but we see that you can actually increase your reach if you have the information coming to you and managing by accurate information and by exception. And then preventative service, we're seeing this in the mid to distant future here. Preventative service right now is you do your PM once every month. You do your PM once a year. You do your PM once every frequency in between. It's really an arbitrary number if you think about it. You're hoping to catch and prevent that failure based on time. Well, there's a lot of factors that cause electronics to fail, and time isn't one of them. Electronics are pretty static. There's a couple of exceptions like capacitors that have acid and whatnot. However, for the most part, it's heat. How much heat? What's the ambient temperature? Are the filters cleaned out? What's the environment of that piece of equipment on where it sits? And we're saying that in the future, you might have a thermal sensor on a certain piece of equipment where it says, hey, it reaches this temperature, go perform the PM service. Because now we're seeing that that's going to fail in the future. This is where AI and machine learning comes into play. Those types of technology will help with the data set that this collects to start building those patterns on where those failures will occur, the stats behind it. And so after listening to our customers, we said, let's see what we can do. And so we've developed Depto. We have data, like a data collection of failures because we have been diagnosing ultrasound machines for the past 12 years. We are experts in medical device operating systems because we were able to develop Adepto. And we also have database development skill sets, and we have ERP development experience. So we can build up platforms to actually start collecting all this data in-house. And so when we say, let's see what we can do, we're thinking, hey, we might be able to accomplish something. And so we want to introduce KV. KV is our patent pending software that we've developed that distributes ultrasound system data to a cloud platform. And this works on legacy machines. So by taking information that Adepto was pulling locally, now we're simply taking that data and pushing it to a cloud platform. Error logs, some user logs we can access. We can access bill of materials. So if there's an error that's reported, well, what does that system look like? And also network information, which is tying into a few questions about cybersecurity. For cybersecurity compliance, you need to validate the IP address, the MAC address, subnet, gateway, all that stuff. Well, right now, it's the old school sneaker net. You have to go to your machine, look at the settings, what's my network settings? Then you reconcile that against what it's supposed to be. If it's the same, you're done. If it's different, pull the plug, pull the network. This thing has been compromised, quarantined, and do something with this system, right? Well, what if I can tell you that all this information can be driven to you real time, and if it sees a difference in your network configuration, it just alerts you. So if you have 1,000 devices, you can have the information of all 1,000 devices being deployed, and if something's different, it pinpoints exactly where it's at, and it pinpoints what the fault is, and then you can make a decision based off the notification that you get. But in short, KV takes it, system data, and pushes it to a cloud. So before we get into this, shall we take a 10-minute break?
That's good.
Let's do that. Not all. We've confirmed difference on other products. Philips IU 90. And to kind of look at that, so she's asked you, we haven't started that yet, because that's a representation of how the way we're being marketed. So we're trying to tackle these.
So.
We pull those logs and
Well,
we should chat after.
You can do it at the end.
Huh?
Though,
You can talk about it all the time. Cell phone transfer. There's an alert.
Set off every alarm.
Play the cord right there.
So now I'm beginning to think, why couldn't you have a USB stick plugged in surely you don't pull the air? And they could connect to it from the cell phone. Now we don't have to get going to the VPN anymore. Because that's been the problem. It's the VPN.
I'm gonna get it in 2 seconds.
I think you locked it in.
It's got more.
I'm trading you in for him, so you can open the door.
And MLBs.
No, exactly. You come to something like this, you're on the cutting edge.
300 pieces of.
I only thought some of imaging was in ultrasound repair, and that's it.
Your guys were thinking way bigger than that. Larry, Taylor, all they want to see is a picture. I wouldn't have like thought of that.
I'll let you finish and then I'll see if you answer my question, because I've got a million of them right now.
Yeah, let's do it. We're really excited.
Yeah, you guys have branched off in a whole different direction.
Yeah.
You're out in a whole new field. Is that new to you guys, or you always done this and I just didn't know it?
We've been developing this for about a year. So we've been doing our own labs, ran a case study.
No, there's just always.
We're in a case study coming up.
So,
you are monitoring machines that
Which
which is 3 hours north of Calgary. I love to sleep. Don't want to go work out there. But this doctor, he's got a couple of selenium and memo systems and face couple of agencies.
Right.
Every time I try to make a service call, it's days before he even shows up to even tell me what I should.
Only to come back a few days later with first.
Exactly right. And so, that's why that's a perfect case. My main.
Thanks a lot.
I'm gonna try and, it's locked now.
I have.
No,
Okay. Okay, there we go.
That kind of scheduled a project and we will. Yeah, it's your phone. But it allows for GPS capabilities for them to just sit in their own home.
I think it's awesome here getting the hospital to allow.
I mean, that's a different animal altogether. There is a land office.
No one's gonna get it, you know.
Just off.
I can hear you, so.
See, I have a Simply Safe alarm system, pretty simple device, okay? But you know what, Simply Safe can communicate with that alarm system. They can diagnose it, they can tell me what's going on, they can test things from everything. They can, what if I had a USB stick I could stick in that Phillips cabinet and they could talk, say by cell, back and forth to it to do diagnosis? And I don't have to worry
Between
about
us friends, because
Where'd you get that?
we're in the mid stages. AWS.
Yeah, look out there.
So I know.
They have these registered.
Well, it's X-ray.
They're my neighbors because we're in Seattle, so they're everywhere, and I am oil man. Fantastic.
I have that keep too every day.
Oh, gosh. My Nest camera's like, hey, Amazon's here, Amazon's here.
My son is a diesel mechanic, and he told the mechanic the other day, or a driver the other day, he works for the main truck, and he told that driver, he says, you better start looking for a job. Boy, you're gonna be self-driving 18-wheelers out here on the road in the next 5 years, and there won't be any.
We cover Tesla, we cover all these Volvos is radiation and all.
Yeah.
But it kind of comes back to that technology. And we're already starting the discussion on the lambda device. With the lambda device, like a computer with the SIM card, and USB. And it's two-way. So what I want to do in the future, we'll talk about that in the presentation. This is a two-way communicator in the 2G network. So we're talking about files that are continuously transmitted. Every 10 minutes, and every 10 minutes, it transfers about 2 megs. Over 2G,
The effect
goes
goes
on.
on.
And so I can do that. The lambda box, and if I have control of the two-way, I can actually inject a data bit into these machines.
Even more.
So you work with Phillips. Our capabilities, you can only do that if you want to install and flash an FPC. Yeah, I can detect the problem. Exfil, I'm looking for a way around Phillips. So if I can install an FPC on an ID33, I can send them an ID33 FPC. Because they're going to put it in. Okay, first now I want to flash. If I got an engineer, I say, fire. All we do is we push it over that platform, push it down to some network, puts it on the lambda device, and then adjusts it into the hard drive of the machine, where it runs all the scripts it needs to run.
Boom.
Try it on.
Insert or mallet, right? We're done. Wow, so that's what we're working on right now. Yeah, you're way ahead of, we're light years ahead of. You are, yep. I was thought I was gonna come in here and have something about repairing ultrasound probes and stuff like that. That's so high, yeah. Which subject to that other hand, you did mention I've been around for, yes, that's the big.
We're focused on selenium, we're looking for.
Have you guys looked into portable detectors for X-ray equipment?
We haven't pushed it through as a modality as a product offering, but for our customers that work right now, they send us the care screen with Fuji's and their GE pads. And we've been,
Oh, you can do flash pads.
we've had about an 85% success rate.
You've got bad.
We're still around,
Yeah,
we're
yeah.
still here.
Did not know you were dealing with them.
So that's kind of for us.
Silver guy plays and flash pads.
We're just very kind of over with we don't want to overpromise and deliver. We'd rather have. How many we'll take it to hospitals, that's our expectations. It's not our software. It's just like.
Yeah, well, everybody's afraid to open up their flash pads.
It's already broken.
Yeah, exactly.
It's already broken.
Hey, it's 80 grand for a replacement, an exchange replacement, so they're taking it back. Canon's doing their own repairs. If you're getting cable, that's the biggest problem. Drop it. It's gonna happen. If you just keep
We had a.
Really? That's really.
Can I have your reaction after?
Yeah, we got lots to talk about.
Yeah.
Yeah, I hear.
Okay.
Yeah, we've been doing this. I'm gonna get away from it. We're working in those trains state. Yeah, they're doing locations on that. But we've been sending our pros to Ascara, and they're saving 20% over GMI and getting good results in GMI. And then bad.
So, don't leave them as.
They've been doing good stuff.
And it could be worse.
But this other device you're talking about.
Sounds good. Maybe you can help us. I'm asking for help.
We're the perfect place for it.
Perfect. Shall we continue? Did everybody get margaritas at the beach yet? Okay, so here's the technical piece. And if you have any questions, please let me know. So when we kind of started the presentation, we talked about how simple the concept of IoT is. But when you kind of start digging into the mechanics of it, and we're trying to connect legacy devices, it becomes actually very difficult to accomplish. And so I'm going to talk about KV, which is here, but I'm going to talk about the whole process on how this works and the magic that happens in the cloud platform, because once you pull the information, that's not enough. You have to do something with it. So we'll talk a bit about what that process looks like, and I'm just going to take my time with this slide because there's a lot of shapes on here. So we start with a medical device, an ultrasound machine in this particular case, but with our capabilities, it can be any imaging device. And then we discovered any device that's electronics based in the hospital that has a memory chip and a network card, essentially. So we use Adepto, and this raw file's in the machine. This is the hard drive. And it has critical performance files on there, and what we call the metadata of the system itself. You have what we talked about before, is your bill of materials, your error logs, there's network logs in there. There's lots of different information that helps you understand the health of your equipment instantly, if you could get them. Now, Adepto gets them, but then it also has another capability, which is being able to work in a Windows environment. Unix as well, but in this particular case, Windows. All ultrasound's basically Windows nowadays. And we're able to run KV that's connected via USB to the back of this ultrasound machine. So all those files, we can copy the files on that hard drive and then distribute them to wherever we want. So before the onslaught of security questions come on, please bear with me for one moment. That's coming, I think, in the next couple of slides here. KV can be a couple of different things. KV is a software that reaches and grabs the logs, yep, and then distributes it to wherever we want. In this particular case, we can go two different ways. We can go to a local server inside the healthcare facility, which operates and respects all of the current IT infrastructure and securities that are already there. Or it can go straight to a cloud. So if it goes to a local server, for us, that is more security for a hospital because that's their device, you're managing it, and then it has only one point of access to the external internet. With that one point of access, if you have 100 ultrasound machines pushing to a single server, that single server will, at a certain frequency that you define, will push it up to a raw file storage place. In this particular case, it could be any cloud storage. We're looking at AWS right now. The AWS cloud is the most secure and the most mature and the most widely used from what we're seeing in the space. But KV can push to the local server. It can run in a USB flash drive. But I was talking to our friend over here, wouldn't it be great if we could actually go out of band? And that out of band is, this can actually run on what we call a lambda device. It connects to the back of the USB of a machine. And it's a mini computer that has a SIM card in it. And it's completely programmable to whatever we need it to be. And so KV would be on that. And it uses probably a 2G network to push across these 2 megabyte files at a frequency we set that's over a secure cell signal. So every device would have its own cell card, essentially. That is the most secure and the easiest approach to get to the raw files in the cloud. So those are the two options that we've seen so far. You can go VPN, you can go FTPS, you can do a lot of different things with this. But in its most general form, you want to keep it in-house and then push it out with one single push at a frequency, or you just want to have it constant, going out of band. Okay. We're seeing a lot of hospitals choose the out of band option. Okay. So once it's in the cloud platform, this cloud platform actually does a lot of different things. So when you're looking at a raw file, has anybody seen a raw error log from an ultrasound machine before? It's an XML file, right? So you got a lot of left gator, right gator equals, whack this, quotes this. 90% of the information is just syntax to make it show up on a web page, because all these ultrasound systems, they run off of Windows Internet Explorer of some sort as a UI. Well, the raw files are pushed to the cloud, and then from here, they're interpreted and prepared to go into a database. What we call it, we're parsing the text, sterilizing the file, but the structure is the same. So if it's a XYZ OEM on ABC model ultrasound machine, all the error log files are the exact same. They just have different information in it based on the errors that are being reported. So we go through and build the algorithms and the code to strip out all the unnecessary stuff and prepare it to put into our database and ingest it into there, so it doesn't append with the information in. And from there, the magic is you do that frequently to where you start collecting a lot of data, right? In this particular case, let's say we push data every 2 minutes. There's a new record every 2 minutes for all this information. So you get the latest error log every 2 minutes. You get the latest bill of materials every 2 minutes. You get the latest network information every 2 minutes. And you don't do anything. You just let the system run 24/7.
So do you collect those data both when the machine is running fine and when it's not running fine?
Absolutely.
And then you compare whatever?
Absolutely.
Yeah.
So I think when we're talking about machine learning and artificial intelligence, I think everybody's really excited on what the technology can do. And technology needs data. If you talk about AI and machine learning, there's still human intelligence that you must put into it to make the artificial intelligence work. And that's by virtue of the data that you're pushing to it. It's finding patterns inside the information that you're giving it. And so without the data, without being accurate data, it's useless. It's going to give you wrong results. So we're able to collect it straight from the machine, putting it into this database and collecting the data over time. And then at the end of it, this is where the key features are. Preemptive failure fault notification. You get a text message on your phone. Hey, machine so-and-so just went down. It's error, blah, 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 blah. And then you can make an instant diagnosis and not even have to get to that machine at all. You already know what to order. You get your replacement parts the next day. You arrive and you simply perform the service to install that part and you walk away.
Is that on PAC's platform?
Yes, this is all going to be most likely AWS, Amazon Web Server platform. Yes.
With PAC's, right?
We have not entered the PACS area yet.
Okay.
There are APIs for us to access PACS, but we really wanted to start with this technology with the KISS model of keeping it simple, stupid. This is for HTMs to diagnose equipment. And then actually there's a slide down here that says APIs to do other things.
Okay.
The metadata of the system is where we live, but the potential to attach that to something else is unlimited.
Okay. I was thinking something else, but the actual data. I was thinking about the patient data, not the actual diagnosis data of the machine.
Yes, machine data only, yes. So there are no HIPAA implications because we're only accessing the system information, not the PHI.
Okay, thank you for that clarification.
No worries. So, any questions on this
Yeah,
one?
I got a small question.
Yes.
So, one of your diagram shows that there looks like a GE Logic E9 concept out there in ultrasound. Will Adepto go in and strip out the raw file,
Yes.
right? Send it over to the cloud, and in the cloud, in the interpret, you're telling me that it will read that database file and correlate it to what the part or failure is. Will it know how to diagnose error codes?
Yes.
Because that is product dependent. Right now, I can pull out a data file out of a I-33 or a Logic E9 and not know what it is. I can bring it up, I can look at it, I can even find a failure by doing the search, but it will not tell me what that means.
Welcome to my world.
So
Thing we want to put the cat lamp right now.
this is where let me just get back here. Sorry. To answer your question. So one of the things that Summit does, I don't want to sell Summit because that's not what we're here to do, but to talk about what we do is we've been offering technical support on all these high-end systems for over 12 years. Our accuracy of first-time diagnosis is a result of us collecting data and manually sterilizing the information and have statistical analysis of when a certain failure happens, what most often fixes the part. So if you get an error 201 on an ID 33, I can say statistically, your AIM board's gonna fail 76% of the time, your channel board's gonna be 18%, and the remaining balance, if your AFP is canceled out. We have that information. We wanna bake that information into this platform with your reports, dashboards, and notifications. So not only would this service that you would be getting from a Summit Imaging say, hey, you got a failure, well, we already have a phenomenal start on what you need. Because a failure is less important than what you need to order to go fix it. That's the most important.
But that's not manufacturer related. This code means this.
Correct.
This is what you guys have compiled,
Yes.
Summit, I should say.
Yes.
Has compiled over the years.
Yes.
Okay.
Yes.
Okay.
Absolutely. And with our 93% accuracy in our first-time diagnosis, we are led to believe by our customers telling us we're the best in the business with having that information. So what's beautiful, notifications sent at the right time with the right information. You can send it to your mobile device, your tablet, if you use a tablet, and some fancy places have tablets nowadays. It's what you got, it's lucky,
We're getting them.
nice. And then computer. So here's how it impacts service. And this diagram was co-developed with some of our reference accounts because we've been working on this with them. And so the top portion is where we're going to talk about first, is what does service look like today? And then what we want service to look like in the future. Service today, we've broken it down by, there's a body inside the bubble. That's the old school sneaker net. You got to show up, otherwise you're not going to have the information. The notification period of a failure, whether it's a preemptive failure, a low critical failure, or a high critical failure, can be anywhere from 2 to 8 hours based on what you need to do. And so that chunk of that service call is the engineer getting the call saying, hey, there's something wrong with my machine, and then the engineer potentially having to walk or drive to get windshield time to get to that device. The reason why it's bottomed out 2 hours is because our sonography customers say, hey, that's about when I actually report the error because I'm so busy, because my workload is jam-packed every day, I really didn't care about that error. I cared more about shutting the machine down, restarting, making sure all of my images are still there to continue my scan.
And then call service guy at 4:30 and expect him to come
Boom.
look at it.
Boom, right? That's a story of NHGM's life. It's not an easy job.
Usually on a Friday afternoon at 4:30.
Yes. And they better be working at 7:30 on Monday. So the HCM must travel to diagnose in the current model. Now that's a really dangerous proposition when a lot of the workforce is about to enjoy retirement. And then when an HCM understands what the failure is, they can diagnose. We're saying 15 minutes to 2 hours and putting in the equipment, putting in the replacement part and bringing that machine up to speed. So we're looking anywhere from 2 hours to about 10 hours of time that this would occur, right? So the opportunities, we can do remote fault reporting. We can actually take the first phase of this service and compress it to about 15 minutes. I can actually take the notification period, eliminate that risk altogether. I can take the HTM travels to diagnose, eliminate that trip altogether. We just cut your field service call in half because you have to go there 2 times every single time to fix an ultrasound machine.
So if you have a system totally down, would you still be able to access the data?
You would see what was there previously,
Okay.
right? And if it's completely down, then we would say, hey, it's pretty obvious that you probably have because it's not turning on anymore, right? But with the frequency of the data being refreshed, we're hoping to see that there's these errors being reported prior to that catastrophic fail. What's most beneficial to you in this system is the preemptive fault failures. You can start seeing overheating errors before that the user would never even see. You will start getting high RPMs on your fans that the user would never see. You get those faults on your cell phone. And then you can actually start actively diagnosing the machine before the sonographer even knows that there's an issue, because you have all these, these diagnostic pieces of information that were invisible to you before. So now we can download this information, whatever device you want, and you can instantly diagnose and say, hey, I got this error 1, 2, 3. That's going to correlate with the service that Summit bakes in, saying, hey, statistically, it's going to be this part. And by the way, I just got this failure. Here's also your latest build of materials that came from the machine as well. So you don't have to go taking out your, your old school notepad that you might have all the part numbers, all your machines written down, or something might have changed something. You have your whole list of every single item that's in your machine generated by the machine itself. And so you have the exact part number to go make the accurate order to replace it.
This sounds very interesting, but how expensive is it going to be to hook this on to, say, each ultrasound machine? Because I know as a third party, we're underpricing the OEMs, and on an average ultrasound machine, there's not a whole lot of money there to work with.
It will be cost effective. We've done research on what the outsourced service contracts look like. And we've also run a comparison against what it costs an institution like yours to carry the payroll to manage that device. And we see that there's a tremendous value here to actually replace the need of finding incredible talent that's going to go up in value by virtue of supply and demand of the HTM workforce. So I would say we'll take the pricing conversation to a different conversation, if I may, but it's of such to where the pricing model is very, very inexpensive relative to current models.
Okay.
Fair?
Are you breaking, or are you FDA certified to add the software to this medical
I'm glad you asked that question. You don't need to be. This is development environment. So by saying that, the Windows operating system, no matter what it is a development platform for software developers to build programs. Now, if we look at the copyright and IP of the technology of software, let's say an ultrasound device, it's their application. They have no rights to the Windows environment. So they're taking advantage of the Windows embedded system to prevent it from getting in. Adepto allows us to work in that environment now. But outside of any application, whether it be any OEM A, B, C, the entire platform is still open for development.
So in order to install this, I would have to have Windows write to the desktop.
Yep.
Which is sometimes shut down by the manufacturer, like GE.
But you have Adepto. Adepto allows you to work in the Windows environment. On these lockdown machines, it allows you all the rights to go in there. And let's say you want to install a printer. You can install printer drivers. You want to remove a printer.
Right.
I actually had to do something really funny that was on the machine. It was on a machine where the printer was disconnected for years. But every time it hit acquire, it would send to the PAX and it would print. The moment they put in a printer, it printed out thousands of images. But it kept going. It kept going. Why does this keep printing? Like, your spool's been spooled up in your printer spool for years and years. We actually used Adepto to get access to the environment, to get to the printer spool, to go kill all those jobs from 2 years ago.
One small question.
Yeah.
So security is a big deal.
Mhm.
Right, for me. And sometimes manufacturers don't really step up to security. they are reactive instead of proactive. Of course, we all know. But if I had a depto, could I come in with a higher security software such as, an off-the-wall, off-the-shelf brand and put it in if I had access to a depto?
So let me answer that in two different ways, because I can't give you an absolute yes or no, because I honestly don't know. What I am saying is that it gives you the opportunity to install whatever you choose to install. It gives you that capability. But being in an embedded environment, it might not have all the right files and DLL directories and all that stuff that Windows needs to just be plug and play. It might not have all those files to make it run. And so it may require some finagling, but when it comes to security, that's just such a hard topic. We are not security experts by any means. That's why we've chosen an AWS platform, because they kind of take care of all that stuff and help us with that process. But when it kind of comes to the security of the device, that's why that out-of-band solution is really
It's
addressing.
AWS, and I've heard lately they are trying to get into a platform-based security.
AWS,
Yes.
yes, they are HIPAA compliant, they are GDPR ready, they are all the things that you would expect.
What about keeping up with viruses?
So the viruses is on the enterprise end. That's
not AWS.
I think they have their own.
I think they do.
They do. They absolutely do. I don't know what they exactly run, but I know they have that. That's why people are using them very aggressively. Google has a great one too. Their enterprise services is great too. But when it comes to the cybersecurity of the device itself, I know that the common standard is people are using McAfee at the OEM level. And if we think that's safe, then we use McAfee, right? If there's something better, I don't know if it's going to run properly, but we do have access to the Windows environment. So sorry for the lack of a direct answer, because I really don't know. Yeah.
I mean, if I can bring it up, we have done an experiment where we've taught KB to detect monochrome. So we can at least see that coming on the kind of our diagnostic side and know that that machine was affected and tell you to quarantine it. But it's just an experiment.
McAfee also does that for me. Raises that little flag. If I can get access to the Windows, on the lower sys tray side, it will raise that little flag.
Sys tray is no problem. You've got access to that.
Okay.
Yeah.
Detecting is easy. Actually blocking it.
Yeah, well, you can.
So if you kind of take a look at how much we're compressing time, that 2 to 8 hours of HCM traveling there to get there to diagnose the machine, notification period, 15 minutes. It's kind of what we're estimating this to be at, because it's all downloaded to your device. And then the post arrival of the replacement part, if you need one, we're not really seeing a big drive down on that yet. I was asked a question during the break of, well, why can't you run a depto on it? Well, there is a possibility to expand this technology in the future where this Lambda device, as a mini computer that has a SIM card, is actually two-way. It can communicate up, but it can also receive information. So there's a strong possibility that we can actually push a depto back into KB from the server. And you arrive and you put your part in, and instead of finagling with all these passcodes, you just say, hey, send an imaging, push down a depto onto that device, and I'll just watch what it's doing. And then boom, it automatically updates as all the scripts that you need to clear the fault on the item you just installed. So that's part of that service that we're looking for, kind of midterm of kind of phase 2 of KB, is having that capability to do that for you, to where you are literally making decisions and allowing the process to roll itself out, making your job a lot easier. So if we kind of look at this, we eliminate notification period, we eliminate HCM travels to diagnose, and so that saves 2 to 8 hours. HTMs all in, $50 an hour. Depending on where you live, could be higher, could be lower, it's $50 an hour. The equipment is, the opportunity cost of that downtime is actually significant. It's $350 to $1,250 an hour. It's a general exam, it's a cardiac exam, could go up or down. That's just a good range. That's in the ballpark. So for every service, a healthcare facility has a savings of $800 to $10,400 per event with this technology. And so when we're talking about Kaiser Permanente, that number is actually much more critical than that HTM $50 an hour. Well, that HTM $50 an hour doesn't go up by virtue of supply and demand. With the current,
Accessibility of a machine to patient care is critical.
yes.
Most of the times we don't service equipment if it's.
Yeah. Mike Busticker and I did a whole video on that on YouTube. So we have a YouTube channel. So if you want to see more of my ugly mug, jump on our YouTube channel. It's all over. But we actually do patient access. We talk about it for a good 10, 15 minutes. Because patient access to Intermountain Healthcare is critical.
Intermountain?
They're saying, we can't run on bankers hours because people get sick 24 hours a day.
Right.
It has to be available. And that's a part of the quality of service that they're driving.
And one of the
towards.
most premium service 24-hour systems there is
Yeah.
active. San Diego is headed that way.
Yeah.
Their model. But my question really is, okay, so the diagnostic purposes and why I'm asking is desktop access is critical if you want to add some remote monitoring. And it's got to be done through the IT system, which I can use several that we have, which is Windows acceptable,
Mhm.
but not comparable to what you got, obviously. But I want to see what they're doing. I want to see keystrokes, I want to see movement, mouse movement, intermittent problems.
Mhm.
The other one is getting some type of feedback as to what the real problem was. And that's why I was asking for machine logs. Can you read machine logs per the OEM standards? Because now with Philips and with GE, I gotta send the logs out.
Yes. So actually, it's absolutely and abundantly clear. We've been reading those logs for over a decade now. When they're being sent to you, they're actually encrypted post. When you actually say, give me my logs, and push it to a USB drive, the encryption takes place then. The native files are just basic XML files. We grab them there. So, yes, we can absolutely read the logs. We can parse those logs, and with the GEs in particular, we can actually say, hey, here's your file. It breaks it down, and here it is. So Kyle, if you wouldn't mind helping me pull up one of our YouTube tech videos, it actually has Adepto parsing out GE logs.
So without Adepto, without any extraficial, if I took a screenshot of the actual error that was popping up on the screen, failed ultrasound or CT or MR, could I get some image to tell me what it was?
Yes, immediately and for free. That's what we do.
What service do I need to have to get diagnosis?
Our phone number. Our technical support is free, it's 24/7, it's 365. Kyle actually came from tech support.
Kyle, I think I mentioned before, right?
He's hard to miss. Kyle's been with us for a long time. And so if you have any questions about errors, we provide that to our customers free of charge. We're not hiding the errors. We want to help you. We want to get this machine back up and going.
Right.
And it doesn't help anybody. It actually hurts everybody, and mostly the patient, if this information is continually guarded. And so we have a technical support team that's available 24/7, and they understand the equipment down to the component level. And when you call them, here's a few stats that we have about the performance of our technical support team. 93% accuracy on first diagnosis, and number two, we diagnose your machine in an hour to 3 minutes on the telephone.
So do you have the same capability for the both GEs and Philips?
Yes.
Because the GE one, you can read it, it's not difficult. It's the Philips one.
That's our specialty. So let's talk to Kyle. He is our man, and he actually trains how to use Adepto and all that stuff in his training classes. These are management of training. Okay. So pretty significant savings, especially when you talk about opportunity cost and downtime. And as we see the market be optimized for patient and equipment use, this is really important. So we want to promote data-driven actions and decisions. And so reporting of critical and non-critical faults, we actually think the non-critical faults are actually more important than the critical because the non-critical typically leads up to a critical. So if I can prevent downtime and actually order the part preemptively and service it at our own schedule and not impact patient scanning, that is a significant savings with that capability. We can collect and report system hardware and performance data, really important to look at the data over time. And you can actually assess which machines are reliable, which ones aren't. Is it a geographical issue? Is it an environmental issue? Is it a user issue? Is it, what is it? And it allows you to get that insight to start deducing what you think it could be. Collect and report network info. You don't have to walk to every single machine to figure out if it's compliant or not. And talking about now accepting alpha and beta testers, we want a lot of feedback. We already have a couple of partners that we're working with. Now we want to actually launch it in an alpha stage to begin with the design, because getting your feedback on what you want to see, when you want to see it, is really important to us. The last thing we want to be is you're seeing notifications left and right because you're managing 1,000 machines. It's not manageable, right? But the other piece is then the beta testing. So we actually have a couple of case studies that we're working on right now. We're in Seattle. We can see machines in Texas, and now we're going to start seeing machines in Edmonton, Canada. Why is that important? Well, Edmonton, Canada, if you don't know, is 3 hours north of Calgary. When that machine fails, you don't want to be the one driving all the way up there just to diagnose a problem and come back, or the part, then drive all the way back up there to service the machine.
And the driving snow.
And there's a lot of snow. Great seeing it though. Security. So I'll field all the questions here. Healthcare facility IT crime. We have 2 different philosophies. Either band connection, that's that cell part I was talking about. And then number 2, local server collection with a single data access point that can be controlled and throttled up and throttled down with security and permissions and user access and all that stuff by your IT department. And so could it be a PPS? Sure. Could it be other things? VPN? Sure. But whatever IT is comfortable with it, we can do it. I mean, you can open up a bunch of ports, you can do custom port, whatever you need. It's a simple process to push the data out. It's just what is the IT security team most comfortable with.
That's probably the feature, and I'm just speaking for myself, is the allowance for you to come in to a backbone and the amount of acceptance that needs to happen by my corporation for you to come in.
Yes.
Very tight. Military and above, tight.
Yeah. And that's why we're selecting AWS. Fully configurable for any IT environment. We just talked about it, and there's no hidden implications. Only machine metadata. So what's really important is APIs available for healthcare facilities in the future. So if you're using some sort of ERP system that has your asset list, another reason why we're selecting AWS is because all the unlimited APIs where we can say, hey, this machine metadata belongs to your asset ID tag here. Make that connection. And so then you can actually start to get a 360-degree view of all your service information, all your service activities that you're tracking now, and attaching it to the metadata of that system. Beyond that, there's a lot of other capabilities of the APIs, connecting PACS information to this information. Very simple. It's just really reconciling the assets in the back end to make this work.
Can you elaborate on APIs?
APIs are, in its most simplest form, it's just a connection to the instance of this database that's in the Amazon platform. Amazon makes it very easy to connect to. And from there, what system are you using over there, Kaiser, to manage?
I have IE33s, LE9s, GE Philips.
What tracks your service calls?
It's XLR packs, whatever.
It's a unique homegrown system. It's a unique homegrown system.
If it's AIMS, it's a
But I
version of
can't-
PeopleSoft.
I
if
can't
that-
know. none of those. It's a unique system, but I can export to Excel easily.
Yeah.
Or HTML.
Whatever your system is, if we have this instance of your asset list running in our cloud,
Uh-huh.
I can connect the two. So it's a standard practice in the data world where you have APIs or the ability to connect one data set to another. And we find that it's going to be critical in the future as this technology evolves to reconcile the asset list of the system that you're using and reconciling it with the performance hardware data that we're seeing here.
So one more question, I'm
Yeah.
sorry.
No, go for it. I love it. I love the question because it makes those boring.
So APIs, I give you an Excel sheet of all my equipment in Southern California. Will you be able to track my software versions,
Yes. That's in the bill of materials.
IP addresses?
Yeah.
DICOM information, addresses?
The DICOM log, whatever is in there, I can pull for you. But if you want me to reach into another DICOM server, we're not going there yet.
That might, yeah, that might.
No, we're not going there yet. We can, but we will not.
But I can provide it for you.
Yes.
Okay.
Maximum. That's what we use for,
Oh, your ERP system?
Yes.
Yeah, so they're all gonna be based on one of two things. It's gonna be a SQL server or it's gonna be an Oracle database. That's pretty much what all your enterprise systems are gonna be. Yeah, we can connect to it. So there's a couple of different things that we're gonna be offering is managing in-house. You have access to your information, your instance on this information, and you do what you please with it. And you can manage it the way you see fit. The other one is Summit can monitor it for you 24/7. And so what this means is that our technical support team would be monitoring your equipment all the time. And we can alert you in addition to the alerts that you'd be getting from the system itself and give you direction on what to do. And so that's something that a lot of our customers are really enjoying because they like the accuracy of the diagnosis that we're providing. So yes, we're gonna bake that intelligence into the notifications as well. But there's times where image quality, the system's not gonna catch image quality. That's where some of tech support comes into play. Okay. So the two things that we're looking at two different audiences here. We want to supercharge the HCM time. Higher uptime, quicker diagnosis, constant monitoring, system failure and preemptive failure information, and predictive failure analysis with some AI and machine learning run against that in the future. But I can't promise AI and machine learning now because there's no data set. But I can tell you what, there's a lot of real intelligence that we can bake into the system right now because we've been doing this for 12 years. And then what healthcare facilities will see is increased revenue per hour, and I'll also see reducing cost of downtime. So I want to end the presentation on an ask, which is we are asking for healthcare facilities and organizations to become one of our alpha or beta testers. So the technology is proven, it works. Now we want feedback from real world applications that are at scale to build out, designing the UI, what that UI looks like. It would be an alpha stage type of activity. But the beta stage is running this platform with the information going on prior to it becoming a full product launch. There's some benefits in return for that, but in doing this is really a great way that if you see this as a solution for your healthcare institution to augment and put in your design feedback into a product without developing this whole product in-house yourself. And so the URL is mysummitimage.com/kdbeta. It's also in the folders you have in front of you. So if you can fill out that information, or you can just say, hey, just notify me when it's ready. That's also an option as well as becoming a subscriber and a customer of ours to take advantage of this service. But we're at that stage now where we're ready to launch the technology is proven, and we're just really want the expertise and the feedback at that user level to refine what we've already put together. Any other questions?